What's up? What's up? What's up? It's your boy, the network, bro. I ain't got my sound effects today. Left the phone upstairs. I'm just trying to race through these videos, like I said before. Anyways, this is today's topic, section 3.24. Describe OSPF packet types. This is a section or a topic in the CCNP route exam code 300-101, version 2.0. Let's take a look at the exam blueprint, see where we came from and where we are headed. Okay, again, this is implementing Cisco IP routing, exam code 300-101. The new exams came out. New ones are coming out February 23rd, 2020. So make sure you're studying for the correct material. New one is coming out. This one is for CCNP route exam. I believe they changed it to CCNP Enterprise. But anyways, we just wrapped up the section configure and verify EIGRP for IPv6. We use Boston Netsim to configure and verify those commands. Or that topic. Today we are going to describe OSPF packet types. So not really hands-on, but we're gonna pull up Gns3 and just look at a couple OSPF packet types and discuss them. We're not gonna do all of them, just a couple of them because I couldn't generate. There's 5 packet types. I only was able to generate 3, and that's all we're gonna do. After that, we're gonna move on to configure and verify OSPF neighbor relationship and authentication. That might be a 2-part video right there, like we did with EIGRP. So, what are the packet types? First of all, how many packet types are there? There are 5. That's just like EIGRP. There are 5 EIGRP packet types. There's also 5 OSPF packet types. This is the OSPF header format. So when you're sending an OSPF message, this is the header that's going to come across it. We're going to pull up Wireshark, and I'm going to show y'all that, right? We are just, for this header, we're just going to pay attention to the type of packets right here. It's circled right here. There's 5 packet types, right? You'll see a 1, 2, 3, or 4, or 5. Whatever number that is, that'll tell you what type of OSPF packet it is. Here are the 5 packet types. 1 is the hello message, right? We're going to just break each one of these down and talk about what they are. We're going to try to make this under 10 minutes because this is just a concept video. We'll do a little bit hands-on, so maybe 15 minutes. So hello messages discovers neighbors and builds adjacencies between them. You say hello, hello, hello. And then a neighbor says hello back to you. Y'all both got to say it at the same interval. So if I say hello 3 seconds, every 3 seconds, you have to say hello every 3 seconds. If our hello timer intervals don't match, then we don't become neighbors. That's just one parameter. I'll discuss the rest of them later. There's also the database description, or also known as DBD, checks for database synchronization between routers. So we need to make sure you have the same amount of link state database, and I have the specific, our link state databases have to match. So I need to have a specific amount of OSPF neighbors information, and you have that information too. I believe you do show IP OSPF database to know what those are. But anyways, that packet there synchronizes, make sure that they have the same. Link state request a specific link state record from router to router. So if something goes down and I don't have information on it and I need more information, I'm going to send you a link state request. Then there's update. So send specific requested link state records. So if, say, a link goes down or a route changes, I'm going to send a link state update if necessary. If you send me a request, I'll send you an update or actually an acknowledgement. And then there's a next link state acknowledgement that acknowledges the other packet type. So if I send you a hello message or actually a link state request, I'm going to send you an acknowledgement or an update, and I'm going to send you an acknowledgement to let you know I got it. Okay, so hello messages. Again, it's used to discover neighbors and serves as a keep alive. What do we mean by that? So I'm going to keep saying, remember the old guy down the block we always check on and make sure he's still alive? That's what keep alive. That's essentially what a keep alive is. I'm going to keep saying hello to keep checking on him, make sure he's all right. Just as what my daughter does for some reason too. Every 3 seconds, I'm going to say hello, 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 to make sure you're still alive. If I don't hear you within a certain amount of time, that's called the dead timer. I believe is by default 4 times the hello timer. Or 3 times the hello timer. So yeah, I believe it's 4 times. It's 40 seconds. My bad. It's 40 seconds, I believe it is. So I say hello every 3 seconds. If I haven't heard from you in 40 seconds, then I consider you dead. It contains the hello interval, which is how many times I say hello, the time, the area, stub flag, authentication, which is passwords and stuff, DR and BDR info, so designated router, border designated, backup designated router, the RIDs of neighbors, basically router IDs, and the router priority. Hello parameters must match, so those have to match. We need to say hello at the same time. As a matter of fact, here's the other parameters. The hello and dead timers have to match. So if I consider you dead within 40 seconds, your dead timer has to also be 40 seconds. If our dead timers don't match, when you do troubleshooting, you see these parameters don't match, and you see that, or if you see there's no OSPF relationship, look at these parameters. This is like the key thing in CCNA fundamental right here. If certain parameters don't match with OSPF neighbors, if these parameters don't match, that's usually the reason why OSPF neighbors aren't, OSPF routers aren't becoming neighbors. Make sure that there's no duplicate router IDs. They must pass an authentication process if authentication is set up. So if your password is a certain, password, I have to have the same password, whatever. Must be in the same OSPF area, must be in the same primary subnet and subnet mask. So if you know about subnetting, they know, they have to be in the same subnet. Must be in the same area type, such as stub. We talked about stubs in the EIGRP. That was EIGRP. We haven't really talked about OSPF stubs and stuff. Regular or not so stubby area. We haven't talked about the real areas. I believe that's later on in this series. Sorry if I'm racing through this. Again, CCNA and CCNP exams have been updated, so I'm trying to churn these out. You may have to, I believe you can slow these down and use YouTube. Just go to the little gearbox right there, and you can see you can change the speed of this video. You might not want to go past normal because I'm just talking a mile a minute right now. So anyways, hello messages like this image right here, they fly around. This is a packet of a hello, an example of a hello packet, right? This is each field broken down. You can pause it, freeze frame it. I'm not going to read all this to y'all. I'll just skim through it though. Network mask is the subnet mask. The hello interval is how many times, or the interval I say hello at how many times. So if I'm saying hello to my neighbor every 5 seconds, that interval will be right here. You'll see 5 seconds or 5 there. That's the interval. The option is the local router advertises its capabilities in this field. Router priority is the priority of the local router. It's used for a designated router and backup designated router. I don't know if you know about that. That's a CCNA fundamental as well. The priority, if it's set to 0, router is ineligible for the election. So remember, we have designated routers who's given updates and stuff like that, and there's backup designated routers in case the designated router goes down. That information is there on the router priority. The router dead interval is when I consider you dead. That number will be there. Designated router lets you know. This the IP address of the current designated router. In other words, the person who is the man in the OSPF area who is giving all these updates and stuff like that. That's where the updates and stuff is coming from. The designated router, the link state database and stuff. Then there's the backup designated router. He's basically the backup of the designated. So if the designated go down, he's going to be one giving the updates and stuff like that. And then the neighbor, this is the router ID of OSPF neighbors or OSPF routers from whom a valid hello packet has seen on the network. I said I wasn't going to read all this to y'all, and I am reading it all to y'all. But that's a packet, a hello packet example. I'm going to show y'all this in Wireshark, actually. This is the database descriptor packet right here. Again, I might be going too in-depth with this stuff, but just, know the concepts of it. That's why they said describe. But that's a packet, an example of a database descriptor. For link state routing protocol, OSPF, it is required that the link state databases of all routers remain synchronized. So your database has to match the database of the designated router. The synchronization starts as soon as the adjacency is formed between neighbors. And they use the database descriptor packets for this purpose. So if I need more information or I need to check my database matches the designated router, this database descriptor will tell me if my database matches with the designated router. DBD packets are OSPF Packet 2. Oh, by the way, these are the packet types. So hello's type 1, database description type 2, link state request is type 3, so on and so forth, right? So, OSPF router summarizes the local database. I'm not going to read all this to y'all. I'm trying not to. But anyways, you can pause this, freeze frame it if you want to. This is the database descriptor. Again, just more information on it for every little field right here, right? I's initial bit lets you know it's the first in a series of database descriptor packages. So if I need to check if my database is updated or not, I'm gonna send. We'll go over the other packet types. I need more information. I'm gonna send requests, and then there's updates and stuff too. But anyways, the database descriptor lets me know if my database is matching with the designated router's database. Pause it, freeze frame if you need to right here. I'm not gonna read all this to y'all. This is separate reading you might have to do on your own. Link state request, the LSR. So if I need more information for if something goes down or if there's a change or triggered update or something like that, I'm going to send a request. Link state request is packet type 3 after DVD packets exchange process. After the DVD packets exchange process, the router may find it does not have an up-to-date database. How does it know that? It may compare it to somebody else, or it just be like, I need more information. I think I'm missing some information. It's going to send a request. The LSR packet is used to request pieces of native databases that is more up to date. I don't believe I was able to generate this, so I'll show y'all this, an example of this in Gns3 Wireshark. This is the packet, what a link state request looks like. It'll show you the type, which is type 3, link state ID, that depends on the type of LSA, and the advertising router, the router ID of the requesting router. So if you get a request, it'll show you who it's coming from. That's who requested it. His router ID is going to be in here. LSU, not Louisiana State University, is link state update actually. So when I send an update, I'm going to send this information. This is a packet type 4. These packets implement the flooding of LSAs. I'm not going to get too deep into this. Here's an acknowledgement. This lets you know, okay, I got your message. So you send me an update, I'm going to send you an acknowledgement saying, oh, okay, I got that. So you'll see these flying around as well. We'll launch up Gns3 and I'll show y'all that as well. Let's go ahead and fire that bad boy up and just experiment just a little bit with some of these packets. All right, so this is the video the topology we use in the configuring suboptimal routing video. We're just going to focus on these two routers right here, and we're going to do something on this link right here. We're going to focus on this link right here between router 1 and router 3. They are participating in OSPF. Let's go ahead and start a capture on that link right there. We're just going to look at the hello packets and OSPF messages that go between that link right here. They're going to be flying between this link right here, between these two routers, right? So we just launched up. Actually, there you go. So we already got a bunch of packets in here, as you can see. We got a hello packet. We got a database description because it just launched up. Let's go ahead and take a look at this hello packet, first of all. So this is better than I thought, man. So I'm glad we did this. So, okay, we got this OSPF hello message, right? We got the header. Remember what the header looked like? Let's take a look at the header again. This is what the OSPF header looked like. Remember, we were focusing on the type right here. Let's see our pop quiz. What is the type for the hello, right? Let's go ahead and take a look at that again. The capture says here type 1. This is a hello packet. Type 1 is a hello packet, right? That's what the header looks like. Again, this is what the header looks like. So let's go ahead and actually let's sit this side by side. We can see this. All right, we got version number, version 2. We got, remember, because version 2 is IPv4. So if it was version 3, that'd be IPv6, right? We got the packet length. We got the source IP, source OSPF router. So this is where the hello message is coming from, the area ID information. Here's the hello packet right here. Remember what hello packet looked like? Here's the packet, hello packet example. We talked about this too. Let's take a look at that example. Here is the hello packet right here. Network mask. I wish Wireshark would have, made it look just like this so you could see exactly what a packet looks like. But no, they just laid everything flat for you. But this is what the packet actually looks like when you look up the RFCs. That's where these came from. So this is the interval. So we're seeing hello every 10 seconds. That was my bad. I said every 3 seconds. That was my bad. I believe that's the IGRP. It's every 10 seconds by default, right? We got our dead timers every 40, so it's 4 times the hello, right? That's the default as well. We have the designated router. Who is the designated router? and the backup designated router. So I'm also the designated and the backup. And active neighbor. This I'm not too sure what that's about, so we ain't gonna worry about this right now. I don't think that's gonna be on the exam anyway. What else we want to look at here? So we also got a couple stuff coming in as we were checking. So that's what a hello packet looked like, right? Let's take a look at this database description. Let's set that side by side with the packet. So that's a database description that came in for link state routing protocol. It is required that the link state databases for all routers remain synchronized. The synchronization starts as soon as the adjacency is formed between neighbors. So that's why these were, I wasn't able to find these at first. As soon as we started, we launched Gns3, I captured some packets, and that's why I was able to capture these database description packets, because we're checking this, make sure that all the OSPF database is synchronized here. The DBD packets are type 2, as you can see. Where is that? Right there. See, there's a 2 right there. The OSPF router summarizes the local database, and the DBD packets carry a set of LSAs belonging to the database. There's the packet length, the OSPF router, area ID, and here's the OSPF database description right here. We got the MTU right there. This is the DBD packet right here. That's it right there. Options to cast NSSA not supported. Break some of that stuff down. This, you know, if you want to break it further, it might be not beyond the scope of this exam. It'll help, but you might not get tested on some of this other stuff. Here's the database description information right here. We got these other packets information. When a neighbor sees an LSA that is more recent than its own database copy, it requests this newer LSA from the neighbor. Let's check that out. Let's see what else we got here. So we got these DBD description, and he's like, I don't think I got that much information. Let me make a request. I think I'm missing some stuff here. Let's pull up this request and take a look at that. So we're gonna pull up this request and take a look at, compare that packet. Glad we did it this way. So here's version 2, right? That means it's IPv4, because remember version 3 is what? It's IPv6. This is the OSPF header still we're looking at though. Type 3 right there, right? There's the packet length, source, area ID. So now here's the actual packet of the link state request. There's only 3 fields, as you can see. The router's LSA, or LS type. It's LSA. Here's the link state ID, which depends on the type of LSA. And then the advertising router ID. So this is the router ID of the requesting router. 192.168.1.1. 192.168.1.1. So that's this IP address checking to get more information from that router. That was the source, right? So what else we got here? So we looked at the hello packet, we looked at the database description, we looked at the link state request. Here's an acknowledgement. Let's take a look at the acknowledgement here. Pull that bad boy up, and here's the acknowledgement. This is basically saying I got your message, I got the update, and we've even, you see, got a red box here, let you know this is a type 5. This is it. This is the type 5 right here. Link state acknowledge, type 5. This is the OSPF header, right? So LSA, this is the acknowledgement right here. This is what, it's only one field. This is the LSA header. Anyways, type 5. And what else did we go over? So we pulled up the hello packets. We pulled up a DBD. We pulled up an LSR. Let's take for we pulled up an LSA. Let's look for an LSU, not Louisiana State University Tigers. Go Tigers. Let's look for an LSU. Here go an update. Here goes some updates. Don't remember if we pulled them up or not, but this is an update. This is what an update looks like. Type 4, as you can see right there. So this is the number of LSAs that was requested. LS type. Let's take a look at that. LSA update. Number of LSAs 1. There was 1. Let's take a look at the other ones to see if that number changed. And then this is LSAs right here. Link state ID and advertising router. Where's the advertising router information? Right here. Advertising router. Here's the ID. LS type. LSA type 1. Let's look at another update and end this video. Let's see. We got a couple updates right here. It says here we got several hello messages, as you can see right here. Notice that this was the last update. Hello packet. We're gonna generate one so you can see how triggered updates work. Right. I'm gonna shut this link right here down. We're gonna shut this link down. We're gonna go into router 3, console into him. We're gonna shut this link down and watch updates come in. So this is FA11, configure terminal interface FA1/1. Shut that bad boy down and take a look at Wireshark. I'm gonna close this guy right here. right? We're going to shut this bad boy down and take a look. Boom, I shut that down, right? We got some updates. We got an acknowledgement. Let them know, hey, something just happened. Something just, look, interface down, detached. We got a FA11 was administratively, was admin down, basically. And it's like basically sounding the alarm. We got an update. We got an acknowledgement. Hello, packet. Hello, packet. Hello, packet, right? That's pretty much it. I think that's pretty much all I got for y'all today. Here's my contact information. That's my YouTube. That is my Twitter handle. Please comment on this video, like this video, share it on your social media, subscribe to this channel, hit that notification bell next to the subscribe button, let you know when these coming out. I'm going to try to churn these out every day. I'm going to try not to miss a day. Please, y'all holler at your boy, Network Bruh.